Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at L-Tri-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. This video will review some common reactions for alkenes and alkynes. The first reaction we're going to go over is hydrogenation. And right from the name gives you the hint of what's going on. Hydrogenation has the word hydrogen in it. So when you hydrogenate something, you're reacting it with hydrogen gas. And so if you remember here, an alkene, first reaction we're showing here, an alkene is unique in that it has a carbon-carbon double bond. And so what happens when you react hydrogen with an alkene is this hydrogen is going to come in and break one of these double bonds. That leaves those carbons now free to create two new bonds, each one with another bond. And that's where your hydrogen is going to come in. So the hydrogen comes in, breaks the double bond, and puts a hydrogen on each of the carbons. Now for this reaction to occur, you do need a catalyst. So up here in blue, above the reaction arrow, this is how they would represent the need for a catalyst. And in this case, it's platinum, nickel, or palladium are the catalysts commonly used to do this reaction. And because you broke the double bond, what you're left with is an alkane. So you're taking an alkene and bringing it to an alkane. As a simple example, show this again. Let's take butene and we'll put the double bond in the middle. And now remember, butene, typically the green here are the hydrogens. So it'll have those eight hydrogens around the butene. And when you react this with hydrogen in the presence of those catalysts, the hydrogen's going to come in. It's going to, let me use blue. It's going to break this double bond, and those hydrogens are going to come over now and attach to those carbons. And so you're going to be left with just plain butane here with all your hydrogens as necessary around. So you're going from an alkene to an alkane, you just break the double bond. The same thing happens with an alkyne, where you have a carbon-carbon triple bond. Only now you're just going to do it if you have a triple bond with hydrogen. Again, you're going to need the same catalyst for it. Only now you're going to need two hydrogens. The reason for that is you have a triple bond, so you need to come in and break one of them and make your hydrogens. But you still have a double bond left, so another hydrogen will come in, break the other bond, and bring in hydrogens here, so that you result in the alkane, which is just a single bond, carbon with a single bond. So it's just essentially two hydrogenation reactions. When you have an alkyne, you have to do two steps. So that's the hydrogenation reaction. The next reaction we'll go over is halogenation. And for this, only alkynes do this reaction. As you'll did I say alkyne? Alkenes do this reaction, the double bond. So again, the name halogenation gives you the clue that halogens are involved. And so you're going to have your double bonded carbon to start with, and then you're going to react it with a halogen. And the halogens over here, fluorine, chlorine, bromine, or iodine. So let's take bromine as the example. You're going to come in with bromine, and it's going to act just like the hydrogen did in hydrogenation. The bromine's going to come in, attack the double bond, and break one. And now instead of putting hydrogens on the carbons, you're going to put bromine on the carbons. And so you end up very similar to hydrogenation, only now you're going to end up with a dihaloalkane. You're going to have a single bonded carbon, but it's going to have two halogens on it. And again, remember, this doesn't work with alkynes. The bromines aren't, let's say, reactive enough to break the triple bond. So this is just an alkene reaction. And then finally, the last reaction we're going to learn about is hydration. Again, this does only work with alkenes. The name gives you the hint, hydration. So it starts with hydrate. Hydrate means to add water. And so in this reaction, you're going to start with an alkene and you're going to react it with water. So again, the main part is to go after the double bond in the alkene. And you're going to react that with water. And I'm going to show water as in this form. Essentially, it's the hydrogen ion and the hydroxide ion. But if you think about water as really a combination of H and an OH, then again, we're doing what we said before with the hydrogen and with the halogens. The water's going to come in and break the double bond again, like we did similarly in the other reactions. Only now we don't have two identical, say, atoms or ions coming in to replace that double bond. Here we have a hydrogen and the hydroxide coming in. So you're going to get a hydrogen on one carbon and the OH on the other carbon. And the rule here is to know which carbon gets the OH is the carbon with the least hydrogens to begin with is the one that's going to get the OH. And I'll show an example of that to clarify how that goes. But because you have a choice here of carbons and which goes on it, you'll have to look at the molecule before you do the reaction to identify which one gets the OH. But before I get to that, I do want to remind that this does need a catalyst, and in this case, you need a strong acid solution. So a hydrogen ion solution, rich in hydrogen ions, or an acid. And the result here, since you broke the double bond, you have a single bond, an H and an OH. When you have a molecule, carbon organic molecule with an OH group on it, that's an alcohol. And you'll learn more about that in the next chapter in our Chem 106 course here. But you're forming an alcohol because of the OH on a carbon. So let's do an example, and I'll try to go through how you pick this carbon with the least hydrogens. So let's just take propene. So here are the hydrogens that you will have in propene. Remember, each carbon has to have 4 bonds, and so this first carbon has 3 hydrogens, second one has only 1 hydrogen, and the end one has 2 hydrogens. The double bond is between these two. So if you look here, the rule says that the carbon with the least hydrogen is going to get the OH. So that's going to be this carbon. So central carbon is the one that's going to get the OH when it reacts. So when we react this with water, and I'll show it again as this, the hydrogen's going to go here, the OH is going to go to that carbon, and this double bond will be gone. So your result here, remember, NH plus, you're going to get C, 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 OH, and then the rest of these are your hydrogens. And this is going to be propanol. and actually you should be able to recognize this is actually isopropanol. So you have to be able to identify where the OH is, and you'll learn that back in I think chapter 10 in our Chem 106 course. There might be a situation where both carbons have the same number of hydrogens on it. So let me just give you, if you had this arrangement, which is butene, if I put in my hydrogens in green here, you'll see on the double bond, the carbons there, they both have one hydrogen. And so neither of them, they're both the same. So here, essentially when you react this, what's going to happen is, let me use a different color here. Half of them will end up like that, and the other half, the OH, will be on the other one. You'll essentially get a 50-50 mixture on that. So I think as far as doing in a test or whatever, most teachers just pick one, just give an answer, say like that. That would probably be fine with most teachers. But if you want to be sure, you can say this, and you're going to make C with H on the other one. Now, this is maybe a bad example because these two molecules, if you look at them, are actually the same thing. And one's just flipped over to the other one. But when they're both carbons have the same number of hydrogens, it doesn't matter where you put the OH. So just remember that too. Okay, well, those are the common reactions for alkenes and alkynes, and hope this was helpful for you. Thank you.